All right, 4.8. You're going to notice that we skipped 4.7. We're going to come back to 4.7. There's some useful information from 4.8 that we can use, but we are learning a absolutely positively new concept and idea here. The idea of complex numbers is for us to be able to solve equations that have a negative under the square root. In Algebra 1, anytime that you had a problem that was the square root of, say, a negative 25, we would say no real solution, okay? Because we can't take the square root of anything that's negative. So anytime this happened in math, we would just say, hey, no real solution. Well, now we have an opportunity to be able to simplify and solve these problems. So it allows us to continue to work with quadratics and work with polynomials. And we just say that this is called the imaginary unit. Okay, so I've had students fight me this and say, well, if it's imaginary, why do we need it? And if you don't go up into higher mathematics, you're right, you're not going to need it. So I try to simplify this into two simple things you need to learn. And you have to just accept them as fact. The first one is that anytime you have the square root of negative 1, we're going to replace that with the letter I. Okay, the I stands for the imaginary unit. So it is now a number in mathematics. Okay, so anytime you see an I in a math problem, it's going to mean there's a negative 1 underneath the square root. And then the second thing is that you need to know is that if you have the square root, if you have I squared, that's equal to negative 1. So there's two very simple substitution things that we need to know. These are the two facts that we are learning, and now we're going to combine those with everything that we've already learned, with radicals and with adding and with multiplying and dividing. So really, these are the two main facts. Anytime you see a negative underneath the square root, you're going to have an I as part of your answer. And anytime that you have I squared, we're going to immediately replace that with a negative 1, okay? So we're going to start off with just basic simplifying. So I want you to write negative 200 in simplest radical form. Anytime that you have a negative underneath a radical, we are automatically going to break this up as the square root of negative 1 times the square root of whatever the number is. In this case, it's 200. Okay, this is what we're doing new. There's a negative underneath the radical, so I'm writing this as the square root of negative 1. Well, what does the square root of negative 1 equal? It equals I. Now, just like we did in last lesson in 4.6, we're going to simplify this radical. So I'm going to try to find a perfect square factor, that two perfect square factors that multiply to 200, and one of them has to be a perfect square. Again, in this case, it's 102. Why didn't I choose 50 and 4? Why didn't I choose 20 and 10? Because I want the largest perfect square factor. So now watch how I write this. And again, what's the square root of 100? I always write the real number first, then I put the I, and then I put the radical. If you wrote it like this, I, 10, square root of 2, it's technically not wrong. It's just this is the more standard form. We always put the number, the imaginary part, and then the radical. So if I look at the square root of negative 150, again, I'm going to break this down to the square root of negative 1 times the square root of 150. And now I'm looking to break this down for perfect square factors. So it'd be I, square root of 50, square root of 6, which would be, does that work? No, not 50, 25. Okay. It'd be 50 and 3, and 50 is not a perfect square factor. So it'd be square root of 25, square root of 6. The square root of 25 is 5. So this would simplify to 5i square root of 6. So now what this allows us to do is anytime I have a radical underneath or negative underneath a radical, I can now simplify it. I'm not allowed to say no real solution anymore. Okay. So what that does is it introduces us to a new number. Okay. This is called the imaginary number or complex number system. And really all we need to know from this is that I have this right here, A plus BI, where this is the real part. So this is the number that we've been dealing with the whole time. And this is the imaginary number. Okay. Now it's possible. So they'll look something like this, 4 plus 2i. The real part would be the 4. The 2i would be the imaginary part. If I had something that was no real part and just imaginary, we call those pure imaginary numbers. So what we're going to do with these complex numbers now is we're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. The same things that we did with the basic real numbers that we learned back when we were in elementary school. So you know how to do most of this stuff. It's just adding a new form. So adding and subtracting complex numbers. So what I'm asking you to do right now is simplify every single one of these radicals individually, okay? So this would simplify the square root of 25. These are all going to be perfect squares. Would be 5 minus, what is the square root of 4? It's 2, and because it has a negative in front, it would be 2i, okay, plus the square root of 9 is 3, minus the square root of negative 81 is 9i. Notice, this negative sign does not do anything to the minus sign in front of it, okay? And then now it's just like combining like terms. We're going to combine the real with the real and the imaginary with the imaginary okay? And you're literally just combining like terms. Like if I could, it's combining like terms. This 5 right here goes with this plus 3. Very simple math. What's 5 plus 3? 8. Negative 2i minus 9i is a minus 11i. This is my complex number. If I ask you for the real part, you would say 8. The imaginary part is negative 11i. Okay, same thing here. Square root of 25 is 5 minus square root of negative 25. Because it has a negative underneath, is just a 5i. Okay, square root of 25 is 5. The negative makes me an I after it. Minus square root of positive 36 is 6. Minus square root of negative 4 would be 2i. So the real with the real, 5 minus 6 is negative 1. Negative 5i minus 2i is a minus 7i. There would be my complex number. Okay, so adding and subtracting, I can't make this easier or say it any, so you're literally just combining like terms. The real with the real, the imaginary with the imaginary. Okay, so if I ask you to simplify this, now look at this problem. It says minus. So just like when we had in Algebra 1, we were combining binomials, we have to change this to addition, okay? So I'm not going to, don't mess with the first one. 7 plus 3i. I'm going to change this to a plus sign, and I'm basically just distributing this to every single term. So negative 1 times negative 2 is a plus 2. Negative 1 times negative 2i is a plus 2i. And then I combine like terms. 7 plus 2 is 9. 3i plus 2i is 5i. When I'm adding, I don't make it an I squared. I just combine like terms, and this would be my complex number. For the next problem, it's a plus sign, so I don't need to distribute the negative. I literally just combine like terms. So if you're looking at this and saying, well, why did I distribute here? Okay, I can, but what's 1 times negative 1? It's just a minus 1, so it wouldn't change it. And what's 1 times negative 8i? It's negative 8i. It wouldn't change it. So I would get 11, okay, 12. My plus negative 1 is 11, and then negative I plus negative 8i is a minus 9i. So there's that answer right there. No need to distribute if it's a plus. You just combine like terms. Okay, so there's adding and subtracting. Next thing we're going to do is multiply these numbers. So to multiply, okay, we multiply the numbers on the outside with the numbers on the inside. Okay, so I have this 7 times 8, which is 56, and then the 5 times negative 10, which is what? 5 times negative 10 is negative 50. Now I'm going to simplify that. 56, square root of negative 1. I'm going to do two things at once. Make sure you understand this. Square root of 25, square root of 2. Where did I get all of these numbers from? Negative 1 times 25 times 2 is negative 50. I have the negative 1 because it's negative. Now, square root of 25 and 2 are the factors of 50, where I have the largest possible perfect square factor from 4.6. So now this is a 56. Everything's being multiplied here, times I, times 5, times the square root of 2. Well, now how do I multiply this? I take 56, multiply that by 5, and I get 280. I always put the number first. You don't have to, but that's just how it's always going to look in the textbook. And you get 280i square root of 2. Okay? So notice, I want you to look at the difference on this next problem. Okay? These next two problems, this is a binomial times a binomial. This right here is there's no plus or minus sign in the middle. So here I just combined and multiplied. Here I have to FOIL. So we have to go back to what we learned and talked about earlier in this chapter with foiling, which means first, outer, inner, last. And again, I always make these markings. It's simple math, but you got to make sure you do it all. 1 times 5 is 5. We're multiplying. My outside is 1 times 6i, which is 6i. My inside is negative 5i times 5, which is a minus 25i. And my last two terms, this is where it's really important. Negative 5 times negative 6, or times positive 6 is a negative 30. I times I is I squared. And again, we talked about this in the beginning. I squared is equal to negative 1. So I'm going to replace this I squared. I can combine my like terms here. 6i minus 25i is a minus 19i. And here I'm going to simply replace I squared with negative 1. It's simply multiplying. So it's 5 minus 19i. Negative 30 times negative 1 is a plus 30. And then I'm going to combine like terms, and I'm going to get 35 minus 19i as my complex number. When I have an I squared, and this might make sense to some of you right off the bat, all it literally does is change the sign of this, and the I squared disappears because I'm multiplying by negative 1. So let's try another one. Okay, first times first. 12 times 3 is 36. My outer gives me a negative 120i. My inner gives me a minus 18i. And my last gives me a positive 60i squared. I'm literally treating this imaginary unit as a variable. It's like an x. Now, we know it's not x. What does it actually equal or stand for? It stands for the square root of negative 1. So again, what am I going to do here? And I'm going to take a shortcut here. 36, combine like terms, minus 138i. We're just combining here. What did I say happens here? This is really 60 times negative 1, which would be a minus 60. It literally just changes this sign. And then I can combine like terms, and I get 36 minus 60, which is negative 24. I always put the real part first, minus 138i. And that would be my final complex answer. Okay, so to start off with this lesson, we have simplifying. You're just going to get an imaginary unit. We have adding and subtracting, which is basically combining like terms. If you have to simplify, first simplify. How do you know you have to simplify? Is if you have a negative underneath a radical. And then multiplying. And the key to multiplying is this right here. If you know I squared, anytime you have I squared, you replace it with a negative 1. It will never, ever, ever stay as I squared. If you have I squared in your answer, it's wrong.